Alright, let's get going on today's video. This one is about carbon and using it to extract metals from their ores. So let's start by defining the key term of the day, which is what is an ore. An ore is just a rock that contains enough metal to make it worthwhile extracting. All rocks contain some metals, so it's important that we have this distinction, and it's only the rocks that contain enough metals that become ores. Here's some examples for you of general ores. As you can see, the metals are attached to oxygens, hydrogens, sulfurs, depending on what's in the environment and what they've bonded to based on their surroundings. So you can get many different types of ores, but the key part is that the metal is currently attached to something else, and that's the problem that we're trying to solve today. Here's an example reactivity series for you. So most reactive metals at the top, least reactive at the bottom. Hopefully you know the majority of these metals in nature are normally found bonded to something else. They're very unusual to be found just lying on the ground. The one exception to this is gold. And gold you might have seen on movies or TV programs that people go panning for gold with the little sieves so that you can just take the chunks of gold out. And we call that a native metal. That means that it's found pure in the ground. And the only reason that happens is because gold is super unreactive. All the rest of them are always bonded to something else. So what we're going to do is we're going to add carbon into our reactivity series, because that's what this video is about today. So carbon goes here between aluminium and zinc in the reactivity series. And what that means is it means that all of the metals below carbon in the reactivity series, we can use carbon to extract them from their ores. Let me show you what I mean. So iron ore, or hematite, or a form of iron oxide, is Fe2O3. Now that can react with carbon, and because carbon is more reactive than iron, it can displace it. And what I mean by that is the carbon can steal the oxygen from the iron. So if the carbon steals the oxygen, that means that I've now got Fe and carbon dioxide being made. This equation isn't balanced, but in the next video, you'll see this in far more detail. Let's have a look back at the reactivity series. So we can see all the metals below carbon, we just heat up with carbon, and that can then displace them and cause them to become the pure metals. What about the ones above carbon? Now normally the ones above carbon we use a process called electrolysis for, and that comes up in another part of your GCSE syllabus that you may or may not have done already. Cool, so a summary for today is that if the metal is above carbon in the reactivity series, then you have to extract it with electrolysis. If it is below carbon in the reactivity series, then we extract it by heating it with carbon, because the carbon can displace the oxygen and therefore make the pure metal as a product.